So we really should start saying, no hablo español, hablo muy mal portuñol. Okay? So sorry that we're going to have to do this in English. Maybe sometime in the future we'll be able to do it in Spanish. Thanks everyone for being here. I'd like to thank the guy from the organization. This event has been, it's an amazing event. I was really, really lucky to actually be here in Malaga in November last year when the event was just kind of starting the discussion. I came here, I visit the venue and everything with some people from the Jugs community. Thanks a lot. So congratulations for all the community here for making this happen. So I have here with me a very, very good friend, Otávio Santana. He is a Java champion. He is a committer of the Cassandra project. He's a committer of OpenJDK. So, this is a guy that's actually behind the scene of a lot of things that's going on. So put your hands together to Otávio Santana.
Okay. Thanks, Bruno. And now it's me, basically the guy who founded the Java community, the JCP member, executive member. Everyone knows as Brazilian Java man, the guy who helped a lot the community, the Java, everything that involved JVM, Bruno Souza.
Thank you. Thank you, everyone. So we're going to talk here a little bit about how we can use some cool technologies to do a scalable application. But one interesting thing is that you've seen those guys, right? Like really big guys and doing all kinds of cool stuff, very, very high scalability things and everything. Most of us are not like those guys, right? Those guys are like having hundreds of, sometimes hundreds of thousands of servers, and they spin all kinds of really crazy stuff. Netflix, for example, has this really, really crazy environment. How many here do testing? You test your application, like you do performance testing in production. Yes, a few people do this, right? So Netflix goes a step beyond, right? Because they turn their production servers off all the time, right? They have this crazy monkey tool that just kind of goes around their production servers, kind of disconnecting things and rerouting networking and destroying their own system, just so they are sure that the system is actually working, right? So we don't need to do those kind of things, right? We don't need to go as crazy. Facebook is the largest content producer in the world. I mean, it's like crazy amount, crazy scalability problems, crazy things. We don't need to do the things, but those guys have one thing in common. What it is, Otávio?
Both use Cassandra as NoSQL database. These guys need more scalability, need more performance, read and write really faster, and also need to retrieve information really faster because the user don't like to wait. Basically that.
So basically they're using the Cassandra database. So they're using something like, oops, this is not working anymore.
Okay,
oops.
Can I help you?
Yes, it's working. Yes, okay. So those guys are using those two tools here, right? Those open source tools, Elasticsearch and Cassandra, to do their thing, right? So the cool thing about those tools is that they are open source, and so you can use even if in your small project. I mean, even if you don't scale as much as those guys, you can use in your small project. I mean, if you have like your small startup that has 5 customers right now because you're just testing the technology, you can use Elasticsearch and Cassandra. If you have a large business, and you can also use those guys. And if you have a really, really large business like Netflix, Salesforce, or Facebook, you still can use those guys, right? So it's really good for you because you can actually use the very cool technology that those big guys are using on your own project.
Yeah, basically why the people mix all these technologies? Because Cassandra, write really faster, really faster, but basically it's really read information by ID information. So if you'd like to retrieve some information, look more about relevance information, search information, maybe you have to do some engine search something like that. So in this case here, we are looking for Elasticsearch.
Right, so basically, we got to, Cassandra is really fast to store and retrieve information, but, it's really fast when it's retrieving by IDs, right? So if you want to do like a more sophisticated search, Elasticsearch is really good for you to do the sophisticated search, right? Yeah. So now, there's another technology, another interesting technology that's CDI, right? So CDI can help you integrate those guys. How, Otávio?
Yeah, because CDI is the glue in JavaEE. Basically, it was born in JavaEE 6, and you can manage our resource just use inject annotation. Actually, you don't need to care how this information become. Just use CDI, this guy can glue it, everything to you.
Right, so CDI can help you kind of, connect to all of those different resources that you need to access without having to worry too much about, creating the resources, deleting the resource, all of that. CDI can manage all of this to you, right? And then there's another, which CDI server we're going to use?
HCDI server, anyone.
I mean, in the implementation, we're going to have a specific implementation here.
You are using the reference implementation that is Wealth.
Okay, so so we can use Wealth to do this, and then, our application that's being written with CDI, we're going to do, two things. We're going to index the data on Elasticsearch, and we'll store the data on Cassandra, right? We're going to do this in the same transaction, right? So we're going to do both things at the same time. To make it easy, and so that way we can have really, really fast storage on Cassandra, and we can search what we need using Elasticsearch.
Okay.
Okay. Then the other thing we're going to do is that, of course, this whole thing is all server-side stuff, and we need to access this somehow, right? So we're going to put a little REST interface in front of this, right? So you can actually connect this with anything. So Jersey, it's a REST implementation that runs on top on any JavaEE application server, right? So we're just gonna, we're gonna run, receive any request from REST. It could be your JavaScripts running on the browser. It could be a client application. It could be another server. It could be anything we want. Just gonna access through Jersey. We're gonna access our CDI code that will do the search, indexing and store in Cassandra and Elastic.
Yeah. Basically, with REST API, can use any technology like JavaScript with AngularJS, jQuery, something like that. Okay,
so now, of course, those guys here run on top of Tomcat, Elasticsearch and Cassandra. They run on their own servers. We're going to show a little bit later how we can actually deploy those things using containers in a minute, right? But one interesting thing is this: Jersey is Java, Tomcat is Java, CDI is Java, Elasticsearch is Java, Cassandra is Java. So it's like, something's not working, but Cassandra is Elastic is Java, Cassandra is Java. So it's like it can be like a full Java solution here, and we're just going to show the code here. It's very easy, right?
Yeah.
Okay. You want to go ahead and talk about the code, Otávio, a little bit?
Let's do it.
Okay, so this is basically what we're going to do. Is going to show a little bit how on CDI here, how we start things, and then there's two paths. That's actually they run the same transaction, but we're going to run the Cassandra side, and then we're going to run the Elastic side, but actually they happen the same transaction, and then we're going to show some searches here, just so you see how easy this thing is.
Yeah, basically we start with REST API. So we are using the JAX-RS here. Basically, you have some method that put developer ATO that has some developer information, and basically start and search all information here. Okay, Bruno, go ahead.
All right.
All right. So basically, what you do here, we create a new event. This event is put information to another implementation. Basically, take fire the developer information to two strategies here. Okay. The first one is Cassandra. Basically, the CDI manages my session to me. If you can see here, I have the produce annotation, basically return the session, the transaction of Cassandra to me. This guy has application scope, and at the end, when the application is finally end, we have the dispose annotation. What it means? Basically, when the application is end, this guy closed the connection to me.
Okay, next one.
Okay, here you can see, I really don't need to care where the information comes. I just need to put the inject annotation, and it's done. It's working. Now here, I just follow the observe to follow this event here. Basically, I follow this event, return the information, put in Cassandra. That is it.
Okay, so that was the Cassandra side, and then we go to Elasticsearch.
There's something happening in the Elasticsearch side. I use the produce to return the client to me, and then in the application, I use this pose to close the connection. Okay?
Okay.
Something, I just use the inject annotation. I really don't care where this information comes. And done. Basically, I follow the event to, I transform my information to a payload because I'd like to retrieve this information different way that I put in Cassandra because Elasticsearch is just to index information, not to store information, okay? So I create this new class here that is developer payload and then index all information there.
Okay, so once we do those two paths, so now we have the data in Cassandra, we have the index in Elasticsearch, so we can now we can actually retrieve this information, right?
Yeah. This one is a really simple information here. Basically, I'm look to developer, look to your salary. So I run this guy from REST API, and then, oops.
Okay. Oh, sorry.
Next one. It basically I run the query, and the execute struct method basically retrieve the information for Cassandra because I search information indexed by Elasticsearch, figure out the ID, and then retrieve all information for Cassandra. Okay.
Okay. So now one of the things that we're doing here is since we have like a Tomcat server and we have the two other servers, we can easily deploy those guys, right, on multiple containers, right? So a quick note about containers here. The biggest thing that we have right now in terms of cloud computing and even in terms of DevOps, right, is the whole notion of containers. I think that's, if there's one thing that you guys should be looking at, we've been, so me and Otávio, together with Edson Yanaga, we have been traveling Europe for the last 2 weeks, discussing with developers all over. We've been in Germany and Switzerland and here in Spain. And the main discussion we're having is about career and how you can improve your career. And the one thing that really strikes out right now is understanding about containers, right? Containers changes the way that we deploy our application, but it changes the way that we develop our applications also. It makes all our development process, all of our testing, and our deployment pipeline much more interesting. So and one interesting thing about containers is that we can easily encapsulate parts of our application in a container and put it to run on different providers. So today every major cloud provider supports containers, right? So basically, what we're going to do here is that we're going to run Tomcat in a Docker container, right? And then we're gonna have Elasticsearch running another Docker container, and we're gonna have Cassandra, running another Docker container. Of course, our example here is just kind of having one container for each one of those guys, but the whole idea is that this can be really, really scalable. You can start as many containers as you want from Cassandra, for example, or as many containers as you want for Elasticsearch. You can also start as many containers as you want for Tomcat, right? So basically, this simple solution that you saw with very, very little code, with not very sophisticated, but in terms of how hard it is to build, it's extremely scalable. And one interesting thing is that once you start using containers, it's also very portable among multiple cloud providers. So you can actually have the same thing you can run. We're going to run here on Jelastic. That's a Malaga-based company, right? So I think that's very fitting that we're going to run on Jelastic. But you can run in any provider. So that's one of the cool thing that we have in terms of containers.
Okay.
Okay? So, oh, I said Jelastic. Jelastic is fun. The funny thing is that the J in Jelastic is also Java, right? So you want to show the demo here? Do you want to run the...
Okay, let's do it.
So there's not much to see, really, right? But let me just kind of... can you see this? No.
Maybe put more zoom in.
Yes, let me just kind of...
Okay.
Right? Okay. So let me just kind of, so we're just doing the REST application, right? So there's not a fancy interface here. It's just kind of you show, you could be calling this from JavaScript, for example, right? But let me just kind of just see what is it. Okay, so just like a quick, this kind of a quick call, REST call, right? That you've seen here. So you're just kind of send an application JSON here, and we send a JSON to our server, right? So this here, this is the BR Java Man guy who he is. That's our Twitter. My Twitter, BR Java Man. Where's yes. Otávio's Twitter? Otávio Java Twitter. So if you want to tweet to us anything, for example, you can use those Twitter. But we are just sending here a JSON to our server, right? Once you send the JSON to our server, it's going to run to that code you already saw, and it's going to be stored in Cassandra, right?
Yeah.
And on the other hand, once you do this, we can just call, oops, where's my URL? Oops,
so basically, our information here is around the developers, guys. So we have the ID, that means the Twitter ID, the resume, random salary, and the name, and more information. What we're gonna do? Basically, we retrieve from ID. That's really easy because you can use Cassandra. Or you figure out some information from the resume. That you need to use Elasticsearch to retrieve information. Of course, you can use Cassandra to do it. You can use, for example, put more index in Cassandra. But what happens if I put index in Cassandra? Cassandra use Bloom filter implementation. If I use more index, Cassandra be more slower. So it's a problem to us. So you can use Elasticsearch to retrieve information, to aggregation of information to us. Because Cassandra is really fast to read and write information, but have a problem when you need to aggregate some information, for example, to put a report. Okay?
So this is a REST call?
Yes, this one's REST call. Basically here I do a get in my API, find two guy who has Java in your resume.
Oh, come on, we didn't put, we are not in the network here.
Oh,
that was bad.
You have no internet? Okay.
That was really
That's
bad.
the problem of the cloud. You need internet here.
Bad demo. Okay, come on, let me turn. All right. Oh, tutorial, yes. 1 second, let me see. Forgot to put ourselves on the network. Okay. Yes. Okay, so come on, let's do it again. Right? Just a little bit like this. Okay. Okay. Right, so you just kind of return this index, right? So that's the return that you got from everyone that knows Java. You're not here, Otávio, so that didn't work.
Yeah.
Yes, you are here. I'm sorry.
Yeah. Okay. Hopefully. Okay. Of course, it's Elasticsearch. You can put more information. You can put more analyzer. You can put more mappings, mapping strategy. For example, anagrams. You can put, for example, chart stripper to retrieve some, extract some information from PDF file, from HTML file, everything. Okay. It's gonna be really easy to use Elasticsearch because you can use a kind of JSON to map our information. You can duplicate our information. For example, you can retrieve information from a name. Just ignore a case. You can use another the same name. Just do not ignore the camel case. Okay.
Okay.
Another example here is just I figure out these guys, the salaries are from these guys, and some and aggregate by currents. If you can see here, it's the program.
Currents right here?
Yeah.
Yeah, that's the currents right here.
Yes. You can see here the currents, dollar, and 25 people. Maybe this guy needs to figure out a new job because salary is so low. Okay?
Right. Okay. So, and then, do you want to see the last one?
No, that's the last one.
Okay, that's the last one. All right, okay. So, let me get back here. Do you want to show the Elastic?
Yes.
Okay. Do you have time? 2 minutes? 20 minutes. Okay. All right.
Okay, we have time
okay.
a lot.
All right, that's good. Okay, so we're running good in time. So, go talk here right there. I'm just going to log in here.
Okay, I can tell some joke.
No jokes.
Okay. Yeah.
Yes, we're really bad at jokes, so don't do this.
Sorry, guys. But the one thing important here, because you can get more scalable stuffs here, because I don't use cache, but I can put more cache, use Docker container. It's so easy. Another important stuff in Cassandra Elasticsearch is if I have one AP, I can retrieve another nodes with the same AP, because these guys use P2P to retrieve information. It uses a kind of gossip protocol. Basically, he uses a broadcast to retrieve our old nodes.
Okay, is that the Otávio test that you run?
Okay.
Yes. All right. So one of the cool things that we are using containers, so that we can actually have. So just seeing here at the panel, this is my cluster at Elastic. So I have. Let me kind of just increase this here a little bit. Better like this, right? Okay. So we have a cluster of servers running on Elastic, right? And so each one of those guys is a container, as we see here, and that the user Otávio has. And one interesting thing is that once we have the containers, we can actually manage them centralized. So all of those guys here are containers that are running on these environments, and our production guys, we developers, what we do is that we put our application inside the container, and we put the container up in the web. Up in the server, and then our productions guys, they can manage those environments any way they want, right? So they can stop, they can start, they can replicate, they can recreate those environments. So they could migrate this environment to different servers. I can just kind of click here and migrate this environment to a different server. So containers is a good way for us to actually pack our applications and make applications available easily in any provider. And one interesting thing is that once we have the application packaged into a container, we can actually move those applications to different cloud environments. So yesterday, we actually had a presentation specifically about containers, where we were migrating containers from Amazon AWS to Microsoft Azure, live, right? So actually, we can even do the migration of those containers live between providers. Okay. All right. Go back to your presentation here. Okay, so all of those guys were running different containers. As I said, they're running Elastic. Now, one interesting thing is this is all Java based, right? And one of the things that we, both me and SouJava, we run, both me and Otávio, we run SouJava, that's the Brazilian Java User Society, where it's a Java user group. And SouJava is on the executive committee of the JCP, where the Java standards are defined, right? And so it's really nice to know that all of these things, Tomcat is an implementation of a Java standard. The JavaEE standard implements several standards of Java. Jersey is an implementation of a JavaEE standard also, for REST access. CDI is also an implement. There's several implementations that are using for CDI. I forgot the name again. Which one you're using here? Welch, thanks. So Welch is an implementation of CDI. That's a JavaEE standard. The good thing about you using standards is that you're not tied, I'm just saying those guys that we use it are one implementation of the standard. But you could use IBM implementation or Oracle implementations or any other thing that, any other provider that you want, because they're standards. Those technologies are going to last for a long time. The fact that they are open source, they can appeal for your project of any size. But if at some point you want to hire support or to hire a company to actually to buy a product from a company, you also have the option, because all of those guys here have both open source and proprietary implementations. You have implementations with no support, you have implementations with support, you have a host of choice here. But now the one interesting thing is that we're here doing NoSQL, right? And Otávio, I don't think there is a standard for NoSQL, right?
Yes, unfortunately no. It's a problem because if I'd like to move Cassandra to another column family like Google Data Store or DynamoDB, I have to move all my code. It's really a problem to me because I have a lock-in here.
Right. It's the one thing that we do, that our companies do, that's really, really important. Is all the code that we write, right? So all our knowledge is kind of embedded in the code that we write. But if every time that we need to, if our provider doesn't support us for any reason, and you need to prove or to move providers, or you need to do something like this, then if you need to rewrite all of our application, that's a problem, right? So we all use it here on when you have the SQL databases.
Yes, there's another problem.
That you can just change the driver, and you can move your application from one database to the next. But that's not true in the NoSQL world, right?
Yeah. There's another problem, because if I'd like to move Cassandra to the something of NoSQL database, I need to learn another API. It's not the same. That's the point. It's a huge problem. You have lock-in problem. You have to move too much code, and also I need to learn a new API to do exactly the same stuff.
Okay, so Otávio, what is the big idea here?
Oh, maybe you can create a standard to do it. Right,
so we are right now working on, with the JCP, working on, and there's lots of people involved. It has not been proposed yet, but there's several people from different big data, NoSQL database, that are working together with SoJava, with Otávio, and lots of us to actually start the discussion of defining a common API that we can standardize it on the Java world, and then we can actually have like full standard and open source based solution for all of that.
Yeah, sure. Also, we have support to CDI too. It'll be easier to use CDI with NoSQL database. Finally, integration with Bean Validator, integration with another part of PIF of JavaEE. So that is it.
And if you want to be part of this, there's very cool news that we're bringing this like very first hand, because 2 weeks ago, me and Otávio were part of the JCP Executive Committee meeting in Germany, in Berlin, and at that meeting, it was decided that to finally release the specification that SoJava has been working very hard for the last couple of years to make it happen. That is to make it really easy for developers to join the JCP. Before 2 weeks ago, to join JCP, you had to get your company to accept this really, really big, like several pages document, very scary, and it was very hard to get your boss to approve this kind of thing. But now we have what we call the associate membership at the JCP. It's very easy. It's a very simple document. Your boss doesn't need to sign. You're not compromising any of the IP of your company. If you do this, it's very, very easy. So we're going to invite you guys to join the JCP. If you go to jcp.org and sign up as an associate, it's completely free and gets you access to everything that happens on the Java standard word, and you can participate on the specification. You can actually participate on this specification that we're going to start. It's very simple. It's an online form that you sign online, and so we'd like to invite you to join. Now, and especially if you join now, in September, we're going to have elections for the JCP, and you're going to be able to vote on these elections, right? So, and actually specifically, and so you can really participate and influence the future of Java.
Okay.
Okay? So guys, thanks very much. That's our Twitter accounts again. We're going to be here for the rest of the day. And if there's anything that we can help you with, or there's anything that we can answer, we're here available. I don't think we have any time for anything. Maybe you do. Oh, we have T-shirts.
Yeah.
Cool. So we have time for T-shirts at least? Yes? Good. All right. This is the best part. Right? That's what you were asking for. I forgot to mention that we're going to have T-shirts. So you actually stayed, not because we so this is T-shirt. Oh, that's Tommy Tribe. Yes, Tommy Tribe is a JavaEE. You see the Tomcat that we are showing over there? So Tommy Tribe is a JavaEE, it's a full JavaEE compliant server based on Tomcat. The problem is that if I throw the T-shirt here, only that guy's going to get. Right? Yeah, okay. That guy right there. Awesome. Okay. No, that's not going to work, Otávio. I think we gotta go.
Okay.
We gotta go here, right? All right.
Okay, Bruno.
Time out.
Oh.
Wait, what? Oh, don't move past it. Okay. All right. So let me go here and start throwing T-shirts. Come on, everyone is standing up, right? Shoot, I'm gonna destroy this. Right. Come on. How about you hold this?
Yeah.
Yes. How about you hold this before I destroy it?
We have a lot of shirt here, Bruno.
Okay. Oh, yeah. Oh, this is good. This is a good to throw because this has plastic in it. All right. So these are the last. Oh, excellent. I'll tell you what. Those are all women's T-shirts, so we don't have a lot of women. Okay. All right. Okay. Now this, I think those will be my hand.
O meio. What? Can I help you?
And then throw.
Whoa!
Okay, so those guys are there. Okay. That's it. Okay, if I didn't destroy the microphone, I'd like to thank you for your participation. You're going to be here until later. Thanks a lot. Thank you. Thank you.